Okay, this is sample problem 2.4. Name the following ionic compounds: MgO, AlOH3, Fe2so43. Okay, so this is the first sample problem that describes naming ionic compounds. Ionic compounds are composed of ions. Ions are charged particles. So for example, if you take a sodium atom, this is an atom, and you remove an electron. Remember, the electron's negatively charged. What that gives you is a positively charged atom, which is called a sodium ion. If the ion is positively charged, it's called a cat, like the animal, cat ion. Here's another example. If you take a chlorine atom and you add an electron, you give it an extra electron. You get a chloride ion. And this one's negatively charged. This is called an anion. Anion. So cations are positively charged ions. Anions are negatively charged ions. Okay? In general, metals form cations and nonmetals form anions. The metals are these elements all the way from here all the way to, I gotta make sure I get all of these here. These are all metals here. It's a lot of metals, right? The nonmetals are the ones here in green and pink. Okay? I guess technically hydrogen is also a nonmetal. So there is a geographic component of the periodic table. The nonmetals are on the right side of the table and the metals are on the left, but all the way through the middle as well. Now these ones here in orange, those are called metalloids, these ones here in the middle. They're sort of in between metals and metals. Okay? All right, so now the general theme for naming compounds that are ionic is you name the cation first. Remember, the cation is positively charged. Then you name the anion, anion, which is negatively charged, positive, negative. So often, because metals are cations and nonmetals are anions, you name the metal and then the nonmetal. And then there are some details. The anion typically has an ending that is changed in such a way to indicate that it's an anion. So it'll end in either IDE, Ide, ITE, ite, or ATE, ate. So the anion generally will end in Ide, ite, or ate, depending on which ion it happens to be. Some of these ions, you'll have to just flat out memorize the names of them. So let's take a look at the first one. The first one is MgO. So what we do is we look for Mg. Mg is right here. That's magnesium. That's magnesium right there. So we name it. Magnesium. Sort of like gymnasium, right? So you just name the metal. You do not say magnesium ion or magnesium 2 or anything like that. You just say magnesium. You just name the element. But for the nonmetal, which in this case is oxygen, right? And oxygen is all the way over here, that's the nonmetal. We're going to change the ending to IDE. So instead of calling it oxygen, we'll call it oxide. Magnesium oxide. Okay? So the name of this ionic compound would be magnesium oxide. Okay. Let's take a look at the second one. The second one is AlOH3. Okay, same idea. The metal is right here, and that's it's either aluminium if you want to use the British pronunciation, or aluminum if you use the American. We'll use the American. Aluminum. Now, if you take a look at this is what's called a polyatomic ion. So unlike O for oxide, there's not one element, there's more than one element. So polyatomic ions, there's a few of them I'm going to list here. Your textbook has more. This is called hydroxide. Here's a few more. Carbonate. Sulfate. Phosphate. Nitrate. Nitrite. SO3 minus sulfite. Get you another ite in there. Okay? Those are just a few of them. Those are 7 of the polyatomic ions. When you read through the section, you'll see a list of a lot of polyatomic ions. You want to know all those polyatomic ions. Learn them all. Okay? So here, the endings are already done. OH is hydroxide. CO3 is carbonate. SO4 is sulfate. PO4 is phosphate. NO3 is nitrate. NO2 is nitrite. SO3 is sulfite. And again, there's others. So it's OH, so you just call it hydroxide. Very simple. So if the nonmetal is just one element, oxygen or sulfur, you just change the ending to IDE. Oxide, sulfide, nitride. If it's a polyatomic ion, you name it based on their given names. Okay? The fact that there are 3 hydroxides in this compound does not matter. That does not affect the naming of this compound. Now, the last one here is Fe2so3, So43. This one's a little trickier. This one has a polyatomic ion, but it also has 2 irons, and irons are examples. So these elements right here, I'm just going to go down to this row because you're never going to have to name a compound with an element down here. But these right here are called transition metals. Okay, these are called the transition metals. And if a transition metal is in the formula of the compound, you have to take that into account. So here's how you do it. Here's Fe right there. This is called iron. So we're going to call this iron, but I'm going to go ahead and put parentheses around the iron, or next to the iron. Then I'm going to name the polyatomic ion, which is sulfate. Iron sulfate. Now here's the tricky part. If it's a transition metal, meaning if it's one of these elements here in the middle, all the way through zinc, then you have to indicate the charge of the ion. And here's how you go about figuring that out. Sulfate we know is -2, but there's 3 sulfates. So that means the charge of the sulfates is -6 collectively. That means the charge of the ions collectively has to be +6. It has to be the opposite of the anion. So if you have 2 irons and the total charge is 6, that means each one is +3. So we indicate that charge by using Roman numerals. So this would be called iron 3 sulfate. So if it's a transition metal, so that's element 21 through 30, all the way through zinc, and these first 3 rows, again, you're not going to have to worry about naming these ones all down at the bottom of the table. Then you have to use the Roman numeral system. So let me remind you the Roman numeral system. The Arabic system, for one, the Roman numeral system, or the Roman system, is an I, capital I. 2 is capital I, capital I. 3, capital I, capital I, capital I. 4, capital I, capital V. 5, capital V. 6, capital V, capital I. 7, capital V, capital I, capital I. Right? Capital letters, that's the Roman system as opposed to the Arabic system that we normally use. It's a holdover from the days when academics in Europe used Latin as the language of science and the language of academics. Still exists with us even today, the Roman numeral system. Okay, so this last one would be called iron 3 sulfate. Okay, the 3 in Roman numerals is an indication of the +3 charge of the iron ion in that compound.